Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right. Well, today we have with us Bill Frasure, who I think I first met you as at a Java Posse Roundup or something as a fire-breathing fire dancer. Was it something along those lines? Is that correct?
Fire juggler.
Fire juggler. Yeah. True. Mm-hmm. I do remember you dancing with fire and breathing it. Is that all true?
I think that was later, though. I think the first time he just came juggled to the Roundup, he wasn't. And that was weird because your administrative person, whose name was Mary Jane, sent me a message that arrived at 4:20 p.m. I think it was on a Tuesday, and that you and Garrett had figured out that this was happening somehow, and you had this last minute thing, but I thought it must have been a joke.
Yeah, I was in town grabbing coffee, and the barista asked what I did. I said software. She said, "Oh, you must be here for Bruce's conference." I said, "I am not. I just live here." She's like, "Oh yeah, Bruce Eckel does this conference every year." Really? I was reading his book last week. I had no idea we were all in the same little town. But yeah, I'll go check it out.
Right. Yeah. And
so you just showed up at the Java Posse Roundup.
And both you and Garrett had these really long hillbilly beards. And I was like, oh, I don't know who these guys are.
Yes. Well, and we thought we knew all of the nerds in Crested Butte.
Well, that was the other shocking thing. Yeah.
There were more hidden nerds.
Yes. Well, I was a recent transplant at that point. I had been here less than a year. And
I didn't realize it was that soon.
I hadn't really integrated with.
And you had pretty much only been doing Java at that time? No, you had also been working in C++.
Yeah. So I guess stepping back a minute to my career background, I did a standard computer science degree, and that was probably 90% C++, and with the occasional delving into other languages, assembly, Lisp, Python.
All the useful stuff.
Yeah. It was an old school curriculum and plenty of stuff that I've never used since.
So not Java?
No, I had not touched Java all through school.
Oh, wow. But your first job was in Java?
My first job was in Java. I graduated from college and started looking for jobs out in Utah. Was just scanning postings every morning.
And that's because you liked the environment there?
Yeah, I had been snowboarding out there my senior year of college, and
so SDD, snowboarding driven development.
Yes, absolutely. That was, I wrote it on one of my goal lists. Before graduation, was just find a way to move to Utah and snowboard and also do software. And yeah, that ended up being Java was what I could get my hands on. And my mom had luckily bought me, it was one of the early Amazon tablets, I think the Fire maybe. And she got it to me, or gave it to me as an e-reader just to use like a normal person, but it was the first Android device that I ever got my hands on.
Oh, wow.
And I was able to use that to just kind of get my feet wet with Java, made some...
So you're building Android apps for the Fire tablet.
So you started by building Android apps.
Huh. Yes.
Okay.
And that would end up being the only Android app I ever made.
Right.
It was very basic, but it was enough to get a feel for the language. And
did you make the Crested Butte bus scheduling app? Was that no?
That would come much later using wildly different technology.
And so you worked for two companies that use Java for healthcare database kind of management stuff.
Yeah.
So it was all back-end Java that you were doing.
So my first job was at Solution Reach, like medical and dental company. And yeah, that was using almost exclusively Java, but there was one project where they gave us a little more freedom to explore, and we did a Scala play application. My friend, coworker Tyler Open at the time, we kind of went off, did the Scala project, did it in a way that would, make any full-time Scala developer cringe, because it was
Java without semicolons.
Yeah, and we were probably even putting semicolons in at that point. Right. It was just, it's a new language, and yeah, I think the files just ended in .scala. That was really the only difference. And yeah, play obviously is Java. Well, it's Java-ish. It actually is a Java framework if you choose. It's Java or Scala. So yeah, we built a project using Scala there, and that just put it on my radar. And at that point in time, I was still 95% Java, a little bit of Scala, and then just generally tinkering with other languages, whatever came up.
But at that time, you were still like, oh, Java's okay. It does the job. You weren't beginning to have the frustrations that you did later.
Yeah, I didn't have anything to contrast it with, really, because, the way I was writing Scala wasn't fundamentally different. So, it was a little more streamlined.
Because I remember when you, at another job, when you went and experimented with Kotlin, you came back saying, the getting rid of the null pointer exceptions is worth the cost.
Yeah. If that was all that Kotlin did, I would have happily
adopted it.
Switched over, because I was spending so much time in code reviews with newer developers at that point, just having to hammer in, oh, wait, you checked for null up here, but you didn't check for it down here.
After this function
and call. At this point in time, we actually have no certainty
anymore
what the state is. And
it's such a mental burden.
The best place to check for nulls is in production when you get the null pointer exception. That's so easy to troubleshoot.
Right, because then it's doing the actual thing. We're joking. But I was telling James that I encountered a tweet in response to something. And the person was asking, well, isn't a null pointer exception the easiest thing to track down and find? And nobody's responded to him. And because I think nobody can figure out, is he joking or does he actually think that because he hasn't had enough experience? Nobody knows. It's too subtle.
It is clear in what the problem was, but where it originated, that is still a total mystery when you get that null pointer.
Why is this thing null? I don't know.
Yeah.
So maybe some background. Bill is our co-author in the effect-oriented programming book that we've been writing. So the three of us have been able to spend a lot of time working on the book and then just generally hanging out in Crested Butte and being nerds together. So it's super fun to have Bill on and hear his journey to ZIO and Scala 3.
Yeah, because I remember you were starting to get into ZIO because you had discovered it first. I don't remember who figured it, who came across it first.
We were at a winter tech forum when we started exploring, even when it was not ZIO, but what was it called before that? It's like Scala ZFX or something.
Oh, you mean just the idea of an effects system?
But it was John DeGoes working on it in the Scala Z code base.
Yeah.
And eventually forked it out of there, but.
Right. Yeah. But it just seemed like, I remember because you were looking at working for Zyverge, but it was kind of like, that's an impossible dream.
Yeah. So we've jumped forward a little bit here.
So you were a happy Java developer and then started seeing some, different ways to do things.
Might make life easier.
Might make life easier.
There was just a certain point where I looked at my GitHub and I realized all of my personal projects where I got to choose the language had been Scala for 4 or 5 years at that point. And it was just increasingly jarring that I was getting stronger and stronger with this one language, and
doing Scala in a way that took more advantage of what Scala brings to.
It was a journey of years to get into the more functional side of Scala, and
it sure is.
But the deeper you got into it, like myself, the more I kind of didn't want to write Java anymore.
Yeah, because early on, I'd figure out one new twist that Scala provided, and I would be able to replicate it in Java without too much trouble. It was a little awkward, but you could do it. But then as you just go further down the path, you realize, okay, I'm contorting Java and trying to use it in a way that it was never designed to be used.
Can't you just use const everywhere?
Yeah.
Final.
But you know, even when I started seeing people doing that with code, before having enough, depth of functional programming, I would look at it going, why is this jerk putting const everywhere? It's just making my life...
Right. Well, and I think that is true. Like, even with the advantages of immutability and everything, trying to do it and enforce it in a language where that is not the focus.
It's not the idiom.
You just spend so much time
fighting.
Yeah, and...
Oh, the joys of not having if else be an expression.
Yeah.
As an example.
Yeah.
All those things.
So... Yeah, once I had that realization of, I actually am a Scala developer, even though I'm still writing Java at my day job. I'm just drifting further and further away from that. I started looking at jobs exclusively for Scala, just decided it's time to make the change. And I made that jump. I joined a company called Axani, a finance company based out of New York City. And worked there for a while, and it was a really great experience. You know, they were doing, maybe not the ideal style of Scala in my mind,
but at least it was Scala.
Yeah, and they were making steps towards, the way that I wanted to be writing code. Some projects more than others, but the most significant takeaway from from that job was meeting Kit Langton,
who we had on the show a while back.
And encourage everyone to go listen to his episode, because Kit is just so enthusiastic and always pumping out new, crazy, fun, artistic projects.
So you were working with him.
And he was working as a consultant from Zyber. No. He was just a regular employee.
He was exactly as I was, just a full-time employee at this company. And when I was doing some kind of goal setting for the next year, one of the things I said, because Kit was on a different team and we had just had some kind of side conversations and really clicked and realized, like, okay, this guy is doing the right stuff.
Yeah.
And I told my manager at the time, all right, my main goal is work on a project with Kit. Like, I don't really care what the project is. I just want
it was like, oh my God, you're coworkers with Kit. Amazing. Hopefully you two can work together more.
Yeah. And then, so I go in, I tell my manager that, and then I talk to Kit later that day. And I think I brought it up, and he was like, oh man, I'm sorry to tell you, but I actually just put in my notice. I'm going to be leaving soon. And I asked him where he was going, just reeling from this devastating news. And he said the one answer that just made the most sense, that he was going to ZIO, which is
the company behind ZIO.
Yes. And I had seen all the open source work that Kit was doing, just building on top of ZIO and just giving it more functionality. And it was much easier for me to accept. I was like, okay, you're leaving, which sucks, but you're going to the place where you belong. That's great. So even if I stay here, like, I'm going to benefit from you being over there. You're going to
And you all were bringing ZIO into the code base there in some ways, right? So you were already kind of doing production ZIO work and seeing some of the benefits of it.
Seeing some of the benefits and seeing some of the pain points. And I think that's what really drove Kit to work on ZIO Magic, which the name doesn't tell you much, but the main thing that it does is, there's this concept of layers in ZIO, which we might get into later. And his library just radically simplified working with those and reduced a lot of the pain. So he says that he's leaving, going to Zyverge, and I continued on at Axoni for a little while, but I was still talking to Kit, and he was just saying how amazing it was working with this new group. And we had a conversation where I said I would eventually, submit an application there and try to join. Some sort of miscommunication happened, and he just told them, hey, this guy wants to join now. Like, let's start the process.
Or maybe not miscommunication.
Maybe he knew exactly what I had said, and he just decided to
let's just see what
take
happens.
The initiative.
Yeah, we need somebody now, so let's just see what happens. And he knew you well enough to know that you were a good fit.
Yeah. So
at this point, we'd already started working on the book.
Yeah.
Effect-Oriented Programming. And
yes.
So you dove deeper into ZIO, and we're already getting to be a pretty expert level developer with it, and teaching others about it, which was
at that point in time. I'm not sure if it was effect-oriented programming yet. I think it might have still been Atomic Scala 3. Which
that's right.
That was the original idea. Is
just
this is going to be a full language, exploration, and I don't know how long we had been doing that. It was at least 6 months before
just looking at Scala.
Yeah, Scala 3, and I know as we got more into the weeds of various features and realized, okay, this is something you can do with Scala, but
well, you and James had been both exploring ZIO for a while, so
and rather than exploring every nook and cranny of Scala that we never actually used in our day-to-day, we started reorienting on, okay, what can be the through line of a book that, addresses the type of software that we are writing, and just looking at some arcane operators that Scala gives you. I don't know that.
I remember there was this point where we were like, we don't want to teach people things that we would later tell them never to use.
Yeah. And when we were doing this complete language overview, if we were going to honestly do that, we had to teach them these concepts.
They would be like, you can do this, but don't
overload really long operators. Yeah.
Yeah.
Yeah, I describe Scala to people now as an experimental language, which has features that have not, necessarily been good, been viable experiments in the long term. And so I think that puts perspective on it, because if you look at Scala and you go, oh, you have the ridiculous operator overloading thing. Oh, we don't actually do that anymore. And it's like, you don't know that from,
and
coming from Java.
Just in my time,
like running the language through like a sifter, and like, oh, there's some really good things that like fall, that become the good stuff.
And Scala from 5-10 years ago, it was just operators everywhere. It was, we have these crazy DSLs and
implicit conversions. That was one where it's like, oh God, let's not do that anymore.
And the classic example of Martin talking about the fold operator, where it's a colon and a slash, and it looks like dominoes
in
falling.
The direction. But which direction? That's always been my problem. Where
Well, but the fold left and fold right have the / and backslash. So
exactly. I know that's to apply direction.
It's very gravity
but
dependent.
Sometimes
Which
it's
direction
from
is
the
gravity?
end that way.
Yeah.
From the beginning that So it's like, no, I've never really internalized it from the direction of the slash.
You have to understand gravity to know which way it's falling. It gets tricky.
And which direction it's falling from.
Mm-hmm.
Yeah. So
So we're beginning to work on this book, diving further into ZIO, and you're interviewing at ZiVerge all of a sudden.
Yeah, and at that point, I guess maybe we had just made the shift, because I think it was more ZIO oriented at that point.
I think it possibly helped the interview, because you said you were able to tell them you were working on a book on ZIO.
Yeah.
So
yeah,
I think you even sent them some of the content so they could see your kind of knowledge and the way you were teaching ZIO.
Yeah, and because we're doing everything, at least currently, open source, every scrap of work that we do on the book, it's up on GitHub for everyone to see, for better or worse. And I know that might not always be the case. We might button it up at some point whenever we actually go to sell it. But for the moment, it's out there for anyone to critique or steal or read.
You see, somebody commented on my commit where I fixed Booker. Great.
Yes.
What did they
It's
say?
I don't know how this person noticed that, I made some change in my GitHub action, changing the way that we load Graal VM in, and saying that, oh, you don't need this step. I'm like, whoa, someone's watching what we're doing.
Out of all the things that I thought someone might look at and comment on, that bit of tooling I was not expecting.
That was great.
But hey, if that's what they're interested in, they can pitch in, give us some
eyeballs.
Yeah, that's right. Many eyeballs. So you got the job at ZiVerge, and now have been full-time ZIO and working for customer, and then I do want to get into the work you've been doing in contributions to ZIO 2, which ZIO 2 just came out and was announced like a week ago today, right? So
yes, it is officially out there.
So that was part of the reason for having you on today, was to talk about the ZIO 2 release.
And one of the interesting things about that is that they had put it into release candidate status, and then started making all of these amazing changes. And I totally understand that, because when I get a book to what I think is the end, then
you're like, I'm so close,
and then suddenly I'll start I'll see something new, and I'll go, oh well, I can't, and because I've tried that before. It's like, no, if you don't fix it, you will be so regretful. But anyway, the point I was making was that they were able to do those things, and that seems to speak pretty highly of the whole ZIO framework, that they can do such dramatic changes and not worry about busting the whole system.
Yeah,
absolutely.
There's a pressure that an RC puts on you, and one approach you could take is, oh, we're so close, let's just get this thing done.
Well, RC means we're not going to make any changes.
Yeah, we're not going to make any big changes. And the philosophy from ZIO was, well, we really need to fix this one thing, and then that happened with a dozen different areas of ZIO.
But huge improvements.
But I don't think. Oh my God, I'm so thankful that they did it the way they did, and I don't think it took the pressure of an RC to probably reveal and push
to focus.
The
well, that's what I was saying. It's like you get the whole book and you start seeing it in its entirety, and then for some reason those things pop up at you, because you're not trying to create new material anymore. You're just saying, how does this look? And they were able to. The fact they were able to do that is what impresses me more than anything, because I build systems into a book so that I can do that, but most software, it's like, oh no, we can't start adding new features after the release candidate. That would be ridiculous. But they were able to re-architect it practically.
I think they were just grinding through a lot of the minutia and gory details, and then once they got through enough of that, you kind of reach this plateau and you can take a moment to look around and reassess and realize
has is terrible. Let's get rid of that.
Yeah, this thing that perpetually confuses new and advanced users.
Fortunately, I never had to understand it. So it's like,
yes. And I'm still dealing with ZIO1 code bases at work, and we probably will be for several months as the migration happens across the ecosystem. But whenever I come across has now, I just grimace because
you know how much better it can be.
And it's hard to spend, potentially days trying to teach a developer this concept that we've completely obliterated.
It turns out it was just a useless abstraction.
Yeah. Mm-hmm. And so, yes, as far as these huge changes in the RCs, I don't know the exact history. I wasn't following it as closely for ZIO1. I was watching it as they approached the 1.0 release, but I think they might have got above 20 RCs. And I don't know if they were changing as radically as they were in ZIO2, but I know Adam, John, Kit, Daniel, they're all trying to keep their eyes on the long-term goals of this project. And yes, it does punish the early adopters who have been following your release candidates. And we got burned by that in some of our book changes, where, I think it was between RCs 2, 3, and 4, they removed all this stuff and then re-added it. And so it was a lot of churn for us trying to keep up with them. But I think on the whole, maybe a couple dozen people felt the pain of that versus thousands, tens of thousands of people once we actually released this thing broadly.
I remember when I was on the C++ standards committee right at the beginning, when they were going from C++ without templates to templates, and people were saying, oh, this is going to break all this existing code and everything. And Bjarne said, he said, yeah, we have only a tiny fraction of the users that are going to be. It was definitely long-term thinking. And just going, yeah, and this will be painful now, but the benefit will vastly outweigh the cost. And I think that's the way you have to look. I mean, that's my attitude. I'm happy to break old things to make the future better.
And you might lose some people in that transition, but I think by and large, those early adopters are the most passionate people about your project. And I think they're going to cut you more slack of just recognizing, okay, you're figuring things out, you're improving it. This hurts today, but it'll be years of improved experience moving forward. And I know that is one of the big goals of ZIO2 is just getting more widespread adoption, which I guess is the point of every project to some degree. But I think ZIO1 was a proof of concept in a lot of ways, and it was really great for that. I know they have managed to just make minor releases on it, that there's not a ZIO 1.1 point anything. It's all 1.0 point. I think we're up to 15 now. So we've had no breaking changes over the last 2 years or so that it's been out.
So was the stimulus for ZIO2 the Scala 3? Did that kind of...
From my understanding, ZIO2 has not really taken advantage of any Scala 3 stuff.
Okay.
ZIO 3 will be where they actually make ZIO be Scala 3 based. Yeah. And so then they can take advantage of Scala 3 specific features. But today, I think ZIO 2 still works with Scala 2.
So I realize we've been talking, we may have lost some people by talking about the details. And what I would like to do is back up a little and say, what problem is ZIO solving? because I think a lot of people that, it's like we're going, hey, this wonderful library. What does it do? Why would I use it?
Well, and you've used it in production, so you've solved real problems with it. So you have an interesting perspective on it.
Yeah. So I guess their kind of mission statement, in one respect, it's meant for, asynchronous concurrent operations. I think that's what the homepage still introduces it as, is a library for that. But I think it solves much more rudimentary day-to-day problems of, even if you aren't doing very complicated asynchronous workflows, I still think your code base benefits from using ZIO. And so ZIO it's an alternative to some of the more kind of
category theory oriented, Haskell oriented.
Yeah, where you just are given this pile of concepts of here's functors and applicatives, and we have built all these things.
And if you already understand functors and applicatives and then it makes sense. But if you're coming in from some other standpoint, then it maybe is, because I tried to understand one of those systems, and it just immediately became overwhelming.
And so as I was getting deeper into the Scala world, I would sit down and think, okay, Kleisleys, I'm going to really focus on these and spend days or weeks just trying to understand this. And I would get to a point where I reasonably understood it, but then it was just this floating concept that I couldn't connect to the rest of my application. I couldn't just bring in this one small piece. It was, okay, you have to understand all of these components and rewrite your entire application for these things to all interact with each other. And that might just be my personal failing, lack of drive or focus or something, but I could never make the transition. And with ZIO, that was the first time that I saw this tool, and the ZIO data type itself, it explains what you need from the environment to run your code, how it could fail, and what the result type is. And those are the three main things that it covers. And I actually saw useful examples of ZIO, and you could take just a piece of your code, start structuring it in this style, and then you could say, all right, I want to do an unsafe run on this little piece of code here. And I was able to go from, okay, I've just got this one network call that I'm using this ZIO data type for, and just have it slowly percolate through. And then, over the course of a couple of weeks, I realized I had got my entire application reformulated to use ZIO. And
so you can incrementally adopt the approach in pieces instead of having to go whole hog on it from the beginning, which can be hard in an existing code base.
So for example, that network call that you mentioned, so there's a normal thing that programmers are used to having to do to make the call and to guard against all of the issues that might happen. And my understanding is that most or all of that extra stuff that you have to do has been folded into ZIO.
Yeah. And if you just wrap any sort of call that might throw an exception in a ZIO, then it will say, all right, you've got a throwable as your possible error type. And that's kind of the first step is, before you fully embrace ZIO and just maximize your type safety and defining all of your error possibilities, you can just start with simply wrap it in ZIO.
And so it's not going to throw an exception anymore. It's always going to come
be returned as your error value,
Okay.
and then you decide what to do
so,
with that channel.
So when I make a call, instead of just getting back the quote-unquote result from the call, I'm getting back an object, a ZIO object, that wraps the result, what might go wrong, what might have changed in the environment or whatever, what effects I may have had. So now I'm getting a bigger thing back, and I have to deal with the error in this case. It says you have to write the code to deal with this error.
Yeah.
You don't have to, but it feels really bad if you don't.
You have to, if you choose to ignore it, you have to use scary method names like or die. Where now which is
nobody wants to die.
It's much more obvious than just having an exception that you're ignoring.
Your app will fail if you don't deal with this.
Yeah. So. And that makes it really easy, in a code review setting of, okay, if you're not familiar with all the moving pieces here, I'm just looking at this one file that somebody else wrote, and I can see that they're calling or die. Okay, that's a big red flag of, okay, our application's going to die here. Is that what we really want to happen?
Ergonomic typed checked exceptions. Ergonomic checked exceptions. It's like giving you the benefits of checked exceptions, which there are benefits of checked exceptions. It's like the compiler is going to be like, you need to deal with this, but making it
or ignore it, or explicitly ignore it, which is what often happens. Yeah,
and I would say it's checked errors because you can use exceptions for all of your error types, but you can use just plain old values.
You can use a string.
And there are a lot of times where that's really all you want is just an error message. Because at this point in time, you're logging it somewhere, reporting it to the user. And at that point, you don't actually care about a stack trace. You're just saying, okay, we have to tell the user that something went wrong. And
one thing we've discovered with Scala 3 is that it gets even ergonomically better when you combine this approach with Scala 3, because then Scala automatically sum types your error channel, your error types together. And so if you have a ZIO that can produce a foo error and a ZIO that can produce a bar error, and you combine those two ZIOs together, you get a new ZIO, which can be the error type is a foo or bar, a sum type on those. Whereas before, the Scala compiler would bring that up to a product, the highest common type of those. Well, product if it was a case class, right? Whereas now it actually creates a new anonymous type that is the sum of the two types. And it just does it automatically, and it's so cool.
So one of the things that we've encountered while exploring ZIO 2 and Scala 3 is these kind of astounding error messages. and now, I mean, I remember seeing them and going, oh, I think this is the best error message that I've seen. But I wasn't clear on, was that coming from Scala 3 or was it coming from ZIO's?
I think we've seen it in both.
I think the answer is yes.
Yeah.
It's both. Scala 3
nature and nurture.
It improves the error messages, but
Kit has done a lot of work on the layer assembly. The layers are how you define the environment in ZIO and assemble it into a graph of things that are needed. And the error messages now around environments and providing them, and when you're missing something, or you've discovered when you have a cyclic dependency, right?
It says that's an error, which I was it keeps coming up with this information that I'm used to having to track down myself.
Yes, and it's
the compiler doing it, whereas most dependency injection frameworks are like at runtime. It's like, oh, you didn't give me one of these. It's like, why couldn't you tell me that at compile time?
Yeah. So going back to the ZIO magic that Kit made for stitching together all your dependencies, and that gave you a lot of extra power. But now that it's been absorbed into ZIO core, he's just taken it further and further of, okay, now it still stitches together all your dependencies, but when something goes wrong, it gives you a level of detail that you just previously wouldn't have thought was possible. Of, you want to run this application, you gave us these 9 dependencies, but we need these other 3. And it will even tell you, we need these other 3 to create these other pieces of the application. And it gives you just the whole layout of your application. Or actually, it gives you the subset that is relevant to your problem. Yeah. It doesn't dump out everything. It just says, here's the problem area in your graph. And you just start plugging in those missing pieces. And it very incrementally walks you towards a working application.
So it seems like in Java, with dependency injection, you could spend a lot of time tracking that kind of issue down.
Oh, yeah.
So you could imagine, well,
which you've done in production systems, I'm sure.
Mm-hmm. So, yeah. And so, but you only know that after you've made this change. You can look back and go, oh, I would have wasted so much time and money of my employer's finances by doing this. But the people who are actually programming in Java, that's just the problem. That, it's just another problem you have to solve. It's just how you do it.
And in ZIO 1, there was much more of a cost of restructuring your application in this style. And you would eventually get the benefits, but you had to kind of wander through this forest of, setting up this boilerplate that you might not really grasp why you were doing it. But now the simplest approach is also the one that gives you the best error messages, where for most of your layers, you can do a 1-line snippet that will take your type and basically transform it into a layer. And once it's in a layer, Kit describes them as these Lego pieces of, all the different dependencies for your application. They're these units, and you can snap them together. And yeah, I think ZIO 1 did that. But now with ZIO 2, they're not just Legos, they're kind of magnetic Legos and self-orienting of, they're going to find everywhere that they are needed and insert themselves, and everything that needs them, or that everything that layer needs, it will go and find that as well.
So it seems like there are these pockets, like we talk about dependency injection. So if you've had a really awful experience once with dependency injection, that might make you go, all right, I don't want to do that again. I'll move to this thing. But then there are all of these other, concurrency, as we've been exploring, and everything, where you could have had nightmarish experiences and go, okay, I would rather not do that again. So that will make me
concurrency and async. Just the programming model gets so much easier for doing it in a way that is correct.
Yeah, and you don't have to worry about mutexes and semaphores or locks. Obviously, we've been dealing with locks recently in our book code, but as an end ZIO user, in most cases, you just type ZIO dot and then check your tab completion options, and you'll see for each par and just all of these methods that match what you want to do. It's not telling you like, oh, this is an arrow or something, which is hard to connect and you have a visceral understanding of it. More often than not, you just type dot and then type a word that seems relevant to what you want to do. And you might have to try a few synonyms, but just type in par and then see what sort of parallel operations come up. And then you can check their type signature and they're going to guide you.
So just cargo cult your way into your solution.
Well, so
the alternative,
I'm a fan of that. If I can get it to work.
The alternative is that you have to understand the algebraic laws that your thing needs to abide by, and then figure out how to assemble the algebraic laws in the way that is correct for your
So it seemed like usability, that kind of programmer usability. Oh, here's a goal of ours. We want to be able to say, take your ZIO object, do dot, and be able to guess your way to a solution, rather than having to understand a huge amount of things in order to figure out what you're going to do next.
And addressing the cargo culting, I would say, that's when you copy paste blocks of code to do what you want. And you say, I don't know what this is, but there's a comment at the top that says it does
planes will land here if you build this tower.
Right.
Yeah, you're right. No, that's not, the cargo culting's not a good example, but somehow just kind of, I don't know, feinting your way into FEINT.
It's very explorer friendly.
I like that.
There are cases where I need to jump over to the ZIO documentation site and try to look up something very particular, but it's a very different experience than some of the alternative libraries I've used, where it's, okay, you have to spend a week with the documentation and then maybe you can start writing some code. It's no, just drop into an editor that's got, good Scala understanding, whether it's VS Code or IntelliJ, and just start exploring, and it's discoverable. And as far as the mathematics stuff, I think some of the alternative approaches are, they basically say, this is math, just transcribe directly into code. Have at it. Where ZIO is built on math, there's very solid underpinnings.
Because isn't John's PhD in math or something?
I believe so.
John DeGoes.
But ZIO's approach is, yes, math is what makes all of this work. You don't need to know or care about that. Just, if you really want to dive, under the covers and start fiddling with that and trying to make changes, you can do that. But if you just want to use this tool, you don't have to know.
You don't have to be a physicist to build something, just an engineer.
Yeah.
Right. So speaking of exploration, you have considered the possibility of doing a recorded exploration, or something that you're going to do online where you play with ZIO code. Has that
live stream Twitch?
Yeah, live stream.
I've done a few Twitch streams. It's certainly low quality at this point.
Sure. But I mean, I like the idea of somebody going in and saying, well, I don't know what I'm doing here, and I can kind of like poke at it and eventually get something to work. I think that could be super helpful.
Yeah, I think
the IDE dot-driven development, where you can explore by just hitting dot on something. And there's a lot of power to that. And I think ZIO is really optimized for that experience. Whereas, it's one of the reasons why I don't think type classes are used at all in ZIO, because you lose that explorability, the dot completion, the list of options that come up in the world of type classes.
The type classes and implicits, you just really don't have to bother with that. You're just using plain old data types, and it's really liberating. And some people might say that that's discarding what makes Scala, the implicit mechanism. It's one of its defining features.
Or it's an experiment that maybe isn't applicable everywhere.
Yeah, and you can do so much without it. But circling back to ZIO 2 in regards to naming all these operators, yes, there have been really astounding fundamental changes that they've made, but then I think equally important is just going through and renaming almost every single method, even the basic ones,
with this idea of usability in mind.
Yes, of if something was just an apply method before, now in most cases that apply method might still be there, but we also have a named variant of it, because that is one thing that some people get tripped up on in the Scala world, is
how do you look these things up?
Yeah. And apply, it's so generic. So things like apply or fold. I was talking to John recently, and he was saying that he really doesn't like fold. He doesn't want to send people in that direction. He wants them to instead, because with ZIO, if you use a fold, you have to provide the behavior for the error case and the success case, and you pass those both into fold. And that's familiar to some people. It's a broad concept, but in ZIO, you should prefer to just say, all right, on one line, we're going to do our catch errors and define our behavior there. And then after that, we'll just do a normal map call, and that's going to apply to the success value. And
that's easier to think about.
I think it is much more direct, and it just...
Well, and it's more granular too, which is what we're always trying to do with functional programming. Just what's the smallest little piece?
And fold can make sense to some people of you're taking this one data structure and you're turning it into a different one. So you could say that's this abstract fold concept.
But there's no reason you can't have the fold and then have the more problem domain oriented combinators on top of that.
Yeah. And I think that is one of the goals of ZIO again. I try to keep revisiting that.
Sure,
that question here is they want to solve problems. They don't want to transcribe clever ideas into code. They want to give you all of these tools that map very smoothly into whatever business problem you're solving. And I think ZIO 2 embodies that way more than ZIO 1 ever did, of just all the names have this unified approach. And previously, like, you had Z managed and ZIO and Z streams, and their method names were similar, but there were so many ways that they slightly diverged from each other. They were written by different developers, separated by years. But now with ZIO 2, we have these codified naming styles of, if you have two variations of a method, like for each and for each par, previously that might have been par for each, but now
everything's consistent. So yeah.
And the problem with that is going back to the dot completion.
Yeah.
If you had for each and then par for each, those aren't anywhere close to each other in the alphabetical listing. But now everything gets more narrowly defined the further you go into the name. So if you're in the neighborhood of the method that you want, then you can just look at the suffix of each of these names and then decide, okay, for each par, or for each par discard, for when you don't care about the return value.
That's really well thought out. And this is one of the things, I had an epiphany the other day why I like Python so much. And it's because the developers, the community or whatever, they don't just take the first solution that they come up with and say, okay, that's cast in stone forever now. They keep trying and redoing it and not stopping until they get something that's truly elegant. And so I really appreciate when somebody does that. And
to be able to have that evolvability,
yes,
there's another piece of it that you worked on for ZIO 2, which was some of the Scalafix rules. So maybe talk about some of those, because I think that's an important thing. Is like, we need to support the evolvability as people, as things, because
otherwise you get stuck and you have this old thing that's really crufty, but everybody has to use it because that's where we stopped.
Yeah.
It's too hard to evolve.
Yeah. So the Scalafix rule, and we still have it, and it still solves some of the migration pains. And I think up until probably RC3 or 4, it was covering almost everything. But then in those last few release candidates, the changes got even more significant. And Scalafix, as impressive as it is very limited in what you can do in a single migration
pass or
yeah, because if you're going from version 1 to 1.1, you can only apply one Scala fix rule to that. So you can't say, I want to run this update and then this update and then this update.
You can't chain them.
You can't chain them. You can't compose these things together, which is very jarring. If
very unfunctional.
Yes. And so you end up doing this, like mutating in place of your source code. And we made so many changes with ZIO2 that for any given piece of code, there might be 2 or 3 updates that need to be applied to that same token in your source. And we're still looking at that and trying to improve it. But yeah, we kind of reached the upper limit of what Scala Fix could do. And the only way to really work around that would have been to say, okay, we have Scala 2.0 dot pre or something, and try to have people migrate through multiple intermediate steps just for the sake of Scala Fix, which, you know, could have solved more problems, but would have been very unfamiliar to people you know, so is this actually 2.0 or it's this kind of weird nether state in between? So thankfully we can still iterate on the Scala Fix rule even now that 2.0 is out, and we can make improvements to it. That can change separate from 2.0 itself, because people just download that from the web anytime they run it. So it's not a panacea, unfortunately. But
it's something you helped make better for the Scala 2 release. And,
yes.
And it's a tool that people can use if they're migrating from ZIO 1 to ZIO 2 and ease some of the pain. Not 100%, but...
Yeah. So that was one of the things I worked on for ZIO 2, but I think the more significant thing that I worked on was ZIO test for this release. And it originally started as just a little hackathon project of, hey, I think we can knock this out in a couple days. We want to share layers between our ZIO tests. And one of the interesting thing about each ZIO test is an instance of ZIO itself. And it's a little strange when you first encounter that, but ZIO applications, once they're fully built, that's just an instance of the ZIO type. But then inside of that, it's all these composed ZIOs. So you have this enormous tree of ZIO types, but they all compose into this one thing. And that's what lets you, take a fully formed application and compose it with another application. And in the test space,
ZIOs all the way down.
It really is. And for our tests, you have a top level spec file, but then you have a suite inside of there, which is a ZIO. And then you have possibly more suites nested inside, or just individual test cases. And these are all just more ZIOs. And that means that all of the cool machinery that is available to you for the ZIO type is available for your tests. And one of the things we wanted to facilitate was layer sharing between separate test files. So if you have some large database that might take 10, 30 seconds to start up.
So that's the reason for sharing, is because it takes a long time to set up the layers.
Sharing some resource, like test containers, like you've done some work with test containers and ZIO test, and that's a good place where there definitely there are cases where you want to share your test container across multiple tests. And that could be for the startup reasons, or maybe sequential, like you want to run one database command and then another database command and make sure that things work as expected.
Yeah, it could be for
sequence.
efficiency or just to be sure that your code really doesn't interfere with other things. And having one shared entity is a good way of checking that. So yeah, it ended up being, instead of 2 days, I think it was more like 6 months before all was said and done. And a lot of that was interfacing with SBT and the way that it expects test frameworks to behave, which it was never written for this style of computation. You know, it's much more kind of object-oriented or imperative style tests.
But you also did something to speed up getting information back from tests so that you could start, you wouldn't have to run everything before you got enough information to go, oh, I need to go fix that.
Yeah, so previously you would have this ZIO test, which is just a tree of other ZIO instances, and we would have to execute the entire tree, and then we would get the output in one big dump. And for a small test file, that would be fine. But as you got into larger and larger tests, you might be sitting there for 20 seconds, not seeing any output at all, and just wondering, is anything actually executing? Like, do I understand this ZIO stuff? But we had to do that previously because ZIO maximally parallelizes every piece of that tree, and for very kind of complex reasons that I don't fully understand, I just take it as a given that Adam and John have figured that all out. Each subtree within the tree, it can be executed in parallel and it won't interfere. It's fine to do. But if you're running everything in parallel and you start just dumping the output naively, it doesn't really make any sense. And
so you can't
it's completely jumbled up. So what I worked on for this streaming output is taking advantage of that tree structure. We had talked about a talking stick kind of concept that starts at the top of the tree and gets passed down to the children. And basically every test that's executing is trying to grab the talking stick. And if it's available at their level of the tree, then you're allowed to print out. But if it's some sibling tree that is printing out right now, you can't print anything out. You have to wait for everything in that other area of the tree to finish. So what you do is you just queue up your output and send it up the tree. And you just have to recognize we don't have permission now. There's other computation happening. We're just going to pass it up the line. But because of the tree structure, everything just funnels up, and as the bottom areas of the tree complete, we know, okay, now that we've returned to this parent layer, we are free to dump out everything from the children.
It's almost like an actor.
Because I'm hesitant to say yes to that.
Or exactly. Another example of thread confinement. You know, it's almost like the top thing is, we have one quote unquote thread to send output, and these things will come in as little packets.
It is certainly, you're dealing with one resource, which is the console output. And if you're just principled about that, well, it's easy to make sure that you can either go one of two directions. You can say, dump everything out as soon as possible. And you can get away with that if you fully qualify every piece of output. If you say what class you're in, what suite you're in, what subsuite you're in, what your test case name is. So you'll have maybe 80 characters of description before you actually get to your test assertion. So you can do that. There are test frameworks that take that approach to just fully qualify everything and we can dump it out
whenever.
Yeah, but that can still make it hard to parse because now nothing is grouped together.
Sure.
Where usually you care about some subset of the test. That's probably what you're focused on. And those can just be scattered anywhere amongst hundreds of lines of output. So you can do that, or you can say, we're going to just wait until everything completes, make sure it's sorted out, and then dump it out.
But you took the intermediate approach.
Yeah, we kind of did a hybrid approach of, okay, we are going to queue things up when it's necessary, but also we're going to eagerly dump stuff out as soon as it's available to us. And that was one of those things that just having an effect system made it much easier to reason about, where printing to the console is an effect. And we can be very diligent about where that happens.
That's cool. So ZIO itself, I think, uses ZIO test for its tests, right?
Yes.
So you have a large code base of tests that you get to evolve the test system on and see how it impacts things.
Yes.
How your changes might break something.
It was good and bad. For one, we have thousands of tests that get run, and so it's usually pretty obvious if you've broken something. But if your misstep was that you weren't actually reporting an error to SBT, well, now you might have broken a lot of things, but your test command still
seems to work.
Says that it passed, but that was just because you weren't actually digesting any of the failures. You were just dropping them somewhere along the way. And so it's hard when you're just changing the ground beneath you. And especially because ZIO cross compiles to native and Scala JS, and then it can also run within JUnit. So there's all these different contexts, and we would work on something, build it out. It'd be working great in the JVM, all the different JVM versions. And then we'd realize, oh no, this is completely incompatible with what Scala JS needs to do with its single threaded approach.
Have you heard much feedback about your, the revamped Scala test?
It's being used.
Nobody's complaining, but
that's a good sign in open source.
No, that's a good start. But it's like, it seems like some people might go, "Oh wow, this is more responsive" or something.
Well, I think the unfortunate reality is a lot of times the nice experience you have, you just quietly say to yourself in your office,
it should be that way.
Oh, cool. And then you move on with your day.
Right.
It's only when there's a problem that you file a ticket or get on the Discord and make some noise about it. Just fine. I don't begrudge people for doing that.
So what's your favorite new Scala 3 features? Any
there's a hard turn. I think we already briefly referenced it with the summon product types, which, to avoid using the jargon, it's ands and ors for your types. And I think it's such a good fit for ZIO, not to bring everything back to ZIO, but it lets you describe your computations where instead of having to put all of your dependencies in some larger super object that contains all of them or extends all of those traits, you just say, I need a user service and a messaging service and a database service. And that is what you see in your type system is just this and this and this. And
which is a product type. And one of the nice features in Scala 3.
Yeah, so you don't have to try to come up with this contorted name that covers all of those.
Well, your name would likely be user service and database service, and
I wanted to be clear.
Whereas Scala 3 is just like I will create a type without a name that is those types handed together.
Because how many times do you have to create a new class just to satisfy some need, and you'll never use it again?
Yeah.
Mm-hmm.
And you don't even care about its name.
No.
Yeah.
What's
and you go, but I have to come up with a name now. And it's like it uses up your cognitive abilities.
When the names just get so long and stupid.
Yeah.
And if you do jam them all into this, 200-line name, you can't piecemeal provide some of them.
Yeah.
Which you can do when the types are just anded together.
Right.
You can say, all right, at this level of our application, I'm going to plug in these 2 pieces, and that's going to leave 4 remaining types that I will pass in at a higher point in the application. And it works in the mirror image of that is the ORs. And again, that fits really well with ZIO for your error channel of saying you might fail with a user not found error, or an insufficient funds, or an illegal argument.
Things that are really disjoint.
Yeah.
And to create a new class to represent them would just be maddening.
Yes. So instead, you just say, these are the 3 possibilities. We know it's going to be one of them. And again, you can handle as many as you care to at any level of the application. You can say, all right, here we're going to handle our insufficient funds error, and we're going to check some other account and try to, get resources from elsewhere.
But ZIO still makes sure that you handle them all.
Yes, because anything that you don't handle, that's going to be sitting in your remaining error channel. So that will be passed along. And then maybe at the end of the world, you have to handle your illegal argument or illegal state or something where, okay, we can't actually recover from this. We just need to dump it out, tell them this blew up. There's nothing we could do. And so if I'm giving my one favorite Scala 3 feature, it's ands and ors for types. There's plenty of other interesting things, and the macros are all reworked, and Kit and Alexander Yoff, they are doing very awesome work with that, but that's not really the space that I operate in. And just day to day, any single action that you're trying to perform, the ands and ors can very quickly just come to your assistance.
Nice. And then the compile errors also get really nice. Whereas we're talking about assembling those types that would encapsulate a bunch of anded or ors types. In that case, you don't get a nice error message that says, oh, I need a foo and a bar, and you only gave me a foo. You also need to give me a bar. The error messages that you get are so nice with the ands and ors.
And again, if you have your different error possibilities, where previously they were all just being boiled down to, okay, there's a throwable. Right. This could fail with a throwable.
Yeah. You have no knowledge of what kind of throwable it is that you need to deal with.
So if you were handling 3 error situations previously that were all, you took a throwable, you pattern matched on it, you handled 3 cases, but then you changed your code and added in a 4th case that was also a throwable.
You have no idea that it was non-exhaustive, that your code is non-exhaustive.
Yeah, nothing alerts you to that fact. Yeah. And maybe something that you could have handled at this layer ends up going all the way up to your application level and failing.
Like a null pointer exception, for example.
Sure.
But aren't those the easiest thing to solve?
Yeah. You see it in your logs in production.
So I feel like I'm now at the point where you guys were when we were just starting this book, in terms of, I think I'm starting to get the way ZIO was. And I think you guys were kind of there at that point. And now I'm starting to see it, but it feels like I still have a lot of catching up to do.
It's been a journey.
Oh, yeah.
It
has.
I've very much changed how I think about building programs and testing programs with ZIO.
There's a lot of things that are
how I model data.
Yeah. It's fascinating.
Yeah, being able to just radically change the behavior of your application, because you can wrap behavior around an existing ZIO instance. You can do stuff like add logging or timing actions. That's something previously you would have to cobble together a dozen lines of timing code.
That's just what you do as a programmer.
And yeah, every single time it was a small wheel, but you were reinventing it.
You had to stop what you were doing and think about something else for a while.
Yeah. And now with ZIO, you just tack on a .timed
or a .debug.
Or a .debug if you just want to print out the output.
Or a .retry. Well, and I do find this idea of being able to say, okay, I have everything set up. Now I'll do this, and I'll look for some parallel way to do it. I mean, without having to go, oh, wait, now we have to re-architect the entire program in order to support concurrency, which is, the traditional way of doing it. And is there the what color is your function problem, where you have to say, oh, this is an async function, and then when I call it, I have to say, oh, wait, I have to do special things. It seems like, are there things like that in ZIO, or is it just transparent everywhere?
The asynchronous is transparent. That is just handled. And now one of the other main features of ZIO 2 I should be sure to mention is the automatic blocking. So historically, if you have blocking code, it's on you as the developer to flag that and handle it on the right thread pool. You have to indicate that. Now with the new runtime system and all this behind the scenes
stuff, which was created during the release candidate.
Yeah. Now it is intelligent enough to see, okay, is this long-running process that you're executing, is it actually executing and making any sort of progress, or is it just sitting still? And once a certain amount of time passes, and this is something you can configure, is
how long it waits.
Yeah. But once it identifies that, it says, oh, you are actually a blocking call. We're going to send you over to this other thread pool where you can block and wait and not interfere with the rest of the application.
So it turns it from a coroutine call to a thread call.
I don't know the actual implementation. It does the right thing magically.
I won't try to answer that here. I'm not going to give the definitive statement there.
Yeah.
I would just say it's a huge part of your brain that you don't have to dedicate to that problem now, where you might be just a really advanced, experienced developer where you know every possible call that can block in your domain. And if you're at your best, you can recognize those and properly categorize them.
But on a bad day, maybe not.
On a bad day, you're focused on other things. You just had a frustrating meeting.
The amount of focus you have to look at every single step and make sure that it works in a concurrent situation.
I just don't want to have to think about resources anymore. I just want to imagine that I have enough.
Yeah,
always.
And we probably should have led with that feature, because that really is impressive.
Yeah, well, there's another related one, which is the automatic resource management, which is in ZIO, was a new addition in ZIO 2, somewhere in the RC section.
Having scope as part of your environment, and I have not fully explored that yet. I just know it's yet another thing that is now codified in our types, and it's in the environment, which gives us much more control over it. And
so you're saying the memory management can be controlled statically rather than dynamically?
I don't know if it's the memory management. It's really about resources that you open and close.
Oh, resources. Okay, not just
so this is Z managed went away. Okay, basically.
Yeah,
you used to have to do it, wrap it in
incorporated
its own data type
into ZIO.
Now it's just part of the environment.
I see.
So the interpreter now has knowledge of opening and closing resources.
Oh,
and
so that's a good one.
It solves, or at least attempts to solve, the issue of we want this tool to be usable by people of nearly all skill levels. I don't know if it's your first day ever writing a line of code. It's probably still going to be a bit of an uphill climb for you, but the idea is you'll be able to onboard new team members that are just out of college or relatively early in their software career, and they've been working in a language where they don't care about blocking, or in a domain where they don't care about that. And they can basically just start writing code and have the blocking managed for them. And maybe in the extreme cases where you need very fine-grained control, you might still have to take over. But for most cases, you just use the operators you want. And if something's blocking, let the combined experience and all the thousands of person hours that have gone into ZIO and its runtime manage that for you.
Yeah.
Because it's always working at the best of its ability. It doesn't have an off day.
I remember way back, early resource management things, writing in C, and it was just like, well, I want to read the file, so got to open it. Now you can read it, and it's like, and then the program will end. So, and I still, I'm going, I think the operating system eventually goes and cleans up the open file handles, right? Doesn't it?
Mm-hmm.
I don't remember. Well, maybe it didn't back then. I have no idea.
And that little piece of code, instead of being this thing that you can now drop into a larger application, it's this cursed piece where if you do put that into a large code base, eventually you're starved of resources, because you just
run out of file handles.
You meant it to be executed as a script and then disappear. And
well, even as a script, I don't know that it wasn't screwing things up.
Yeah. Right.
But it was just like, and memory allocation. It was really just a very narrow, I guess you could almost say selfish, immediate look at, and I've now since seen it in other young programmers. It's like, well, it works. Stop complaining, you old so-and-so.
It's selfish, isolated code versus something that is team-friendly, and that you can just say, all right, I spent a couple hours on this. I can put that into practice, or just drop it in to this larger project and actually take advantage of that, rather than, oh, that was just burned time. It solved this one thing and is not appropriate anywhere else.
So ZIO 2, fewer foot guns.
Yeah, far fewer.
We keep the foot guns locked in a cabinet.
That's right. Exactly.
Yeah.
You have to go put in the code and get them out and load them, and
it must be this tall to use this foot gun.
Yeah, if you want to make an unsafe call in ZIO 2, it's outrageous how many times you have to write the word unsafe now. I think it's 4 separate times. It's like unsafe, and then runtime unsafe,
right?
Run unsafe.
I didn't know at the time. I thought, I did the thing that I saw in the instructions. It worked. There wasn't any flag that was saying, but if I had to write unsafe at all, it's like, oh, I'm not sure. I don't
this
feel
feels unsafe.
It feels, I'm not that comfortable with this for some reason.
Yeah.
Maybe it's that word. So to have that, I really like the self-documenting names of these things. That's to me, that could be a whole study for computer programming in general. So like just naming things so that they're look upable, they show up with the dots, they're in the same region, so you are actually comparing things, all that. That's brilliant.
Some people might think it's a trivial detail, and it's not going to make a big difference at the end of the day, but I think it drastically changes how many people have a good first experience and think, oh, okay, this is something I can use, rather than, I'm not good enough for this. I need to just go back to the quote unquote dumb style of programming, because I'm not worthy of using this tool. I can get
something to work there, but here it looks like I have to learn this vast, I have to learn functional, and I have to learn this vast array of category classes theory. Or category theory or all this stuff. And it's just, I actually have to write some code at some point, and I don't see where that happens in this situation. I mean, I've had this feeling when looking at this stuff. So, yeah. But on that note, it seems like we've probably
super fun.
Yeah, this was really
congrats on ZIO 2. Thanks for your contributions. It is awesome.
I was one small piece of the puzzle. I stand in awe of my coworkers at Diverge.
Isn't that a great thing to have in a job, to be able to go, all my coworkers are so much better than me, and I will learn so much from them.
The people in charge should be in charge. They weren't in the right place at the right time and lucked into their position.
Or somebody's college roommate.
Yes. There was no just luck of the draw there. Mm-hmm. They are the ones leading the charge, doing the difficult work, getting feedback, and just continually refining things. And it's just so much fun to be in the room and watch that all take place.
Yeah.
Awesome. Well, thanks, Bill.
Yeah. Thank you all.